Good morning. My name is METİN ARIDAŞIR. This is 14th part of my explanation of my theory. Now I'm going to make experimental proposal to determine electrons' velocity and position at same moment according to my theory and my formulas. Yes. Remember X-rays continuous spectrums. Here starting point and this axis is wavelength, this axis is intensity, energy. Here according to my theory, remember, this continuous spectrum represents free electron motions, but relocating free electron motions, waves, variability. Okay, it represents that, which the electron motion forms, the electron motion form which is relocating at a certain velocity, v e, in the direction of 0 degree. Okay. Again, remember here, this point 90 degree, this direction 0 degree. Usually, in accepted physics theories, X-rays continuous spectrum graph at these graphs, this point lambda minimum lambda, they say, only lambda. But nobody explained this. Lambda, only lambda. Wavelength. But according to my theory, this last point represents 0 degree of relocating electron motion form, and lambda n minus delta lambda. Why? This was my formula, lambda n minus delta lambda cosine alpha. Cosine 0 degree equal 1. Okay. Because of that, lambda n minus delta lambda. This point. And this point represents 90 degree of relocating electron motion forms, lambda n, because of here lambda n minus delta lambda in the 0 degree direction, here shortened way, but here lambda n minus delta lambda cosine alpha. Remember, cosine 90 degree cosine equal to 0. Because of that, we say only lambda normal, this side. If an angle at that angle, lambda n minus delta lambda cosine alpha, whatever, okay. For us, it's not important angles now, these different angles. At first step, I will find delta lambda for finding electron velocity. Again, I don't want to confuse your mind now. Say, for instance, lambda n equal to 0.6 nanometer, okay? Then, this means there is an electron which has normal wavelength initial electron wavelength, radius or equal to 0.6 nanometer. Okay, according to my theory, there are different wavelengths electron motion forms in universe, freely wandering or tied, bounded. Now, we apply voltage (30 kV) or 30,000 volt. That electric potential will gain the electron velocity. But what's quantity of that velocity of electron? We will find now according to my theory and my formulas. At 30 kV, we know at 30 kV, lambda n minus delta lambda min equal to 0.0409 nanometer. In accepted physics, they say lambda minimum, but according to me, lambda n minus delta lambda equal to same for 0.0409 nanometer. Okay, not lambda minimum. Yes. Now, firstly, according to my theory and my formula, we will delta lambda. Lambda n minus lambda n minus delta lambda. This is delta lambda. Okay. Lambda n 0.6 nanometer and lambda n minus delta lambda 0.0409. Yes, we will subtract 0.6 minus 0.0409. Delta lambda equal to 0.5591 nanometer. We find delta lambda. Okay, this was first step. My formulas. Now, according to my theory, frequency constant at every point for every wavelength, frequency is constant. Okay, remember, wavelength is changing. Respect to locating electron motion forms direction and velocity. But in that time, its frequency is constant according to my theory. I have told you this before. Frequency constant, while this is provided that delta lambda divided by lambda n equal to electron velocity divided by c, speed of light. This is my another relationship, and don't confuse your mind with Doppler shift, because of that they say frequency shift, appearance, wavelength, etc. Okay, fictions. No, really shortened wavelengths. In universe or in smallest part of universe or smallest scales of universe or largest scales universe, this formula is real. It represents real shortening or enlarging of wavelengths without changing frequency. Okay. Now, we put the quantities on this. From here, electron velocity delta lambda multiplied by c divided by lambda n equal to 0.5591 multiplied by divided by here 0.5591 divided by equal to finally, I found electron velocity by applying 30 keV electrical potential to gain the electron motion form velocity. Its velocity under these conditions is 279,550 kilometer per second. Okay. Under these conditions, we find, according to my theory and my formulas, electron velocity. We found okay. Again, we mustn't forget yes, now this was the first step. Second step for our experiment, okay? This graph from now on is representative graph. That's not important so much, but for imagination, for putting something in the context of my experiment, I will show you this graph, okay? Lambda n equal to n lambda n minus delta lambda equal to delta lambda. Oh, it's not important now. Okay, here, this is electron's velocity. Now, this is starting moment, T1, and starting point. Of relocating of free electron motion form by means of applying, say in here, 30 keV electric potential. When you apply this keV at this point, say, from A point, okay, and at this starting moment, here, We will put between these 2 points, or it's not important between this point, between another point. It's not important, only representative, okay. A plate. Okay. This is a plate. We will put somewhere, but we know which where. This is A point, this is B point. Okay. And we know this distance. We know starting time, finishing time, T2. Starting time, T1, finishing time, T2. Don't confuse, please. Huh? This is a plate. Okay, this is B point, and okay, we apply 30 kV. We know that time. We know starting point. Okay, say X-rays production system. We know that place from that system, from X-rays production system. We know that starting place. This plate is special plate, which is when electron motion form strike it, electron diffraction. Displaying time, just that time, because of when electron motion form from here to there at 279 279,500 2079. I beg your pardon. Wait a moment, please. I beg your pardon. Delta lambda I will compute again. Yes, this is the velocity of electron motion form. $279.550 kilometer per second. 0.559 divided by approximately 93% of speed of light, electron velocity coming. When this electron motion form arrives here on this plate, it will stimulate the plates, and stimulating time will be obvious. We can measure the stimulated times by effect of relocating and striking electron motion forms to that plate. And we see in the same time this diffraction. Okay. And then at that moment, we will know the velocity of the electron motion form and where is it. At same moment, we will know. At same moment, simultaneously, where is the electron and what is its velocity. It is possible with this experimental proposal. We can easily compute. We know this distance.